Welcome to the next practicals of Introduction to Structured Programming. Today we have, as always, a lot of things to do, so we start directly into them. So what is the plan for today?
Let's get started. So first we're going to talk about organizational matters, especially assignment 2. Then we'll continue with stack versus heap and the heap function and how to properly use them. And then at the end, I'll demonstrate a two-dimensional array on the heap, which might help you for this assignment.
So let's start with the organizational matters. And there are many things today, and we start with the coding sessions. In the moment, the fourth block is going to be released. So either it's already available or in a few minutes. So you can register the same as before, so I don't think I have to explain anything more here. So let's continue with the next part.
Okay, so the grading for assignment 1. The assignment interviews are until Monday and the results should be uploaded every second day. And if your results are still not online, don't worry. Just contact us if they're not online after all the assignment interviews happen.
Yeah.
So
now it gets interesting. Assignment 2. There was an announcement today that the deadline will be extended by 5 days. So the new deadline is now on Monday, the 11th of December. And of course, we also have to shift the assignment interviews because they would have started on the 11th of December, which is not possible. So we shifted them to be a few days later, so starting from the 14th until the 20th. And of course, the exact date will depend on your tutor, and they will announce once the dates are public, but we have some time until this happens.
Okay, so again, we have question hours to help you with assignment 2. The first one will be, no, not the first one, but the next one in person will be on Monday, I think, so it's the 4th, at 18 o'clock in Hörsaal 3. And then the next one is on Discord on the 1st, so...
This Friday?
Yeah,
Actually tomorrow.
Tomorrow. And there will be more announced on Discord, probably every day.
Yeah, and this also brings me to the message in the chat, how you can expect from a beginner to do assignment 2. We know certainly that this is a long assignment and it might be difficult to you, but we will really offer help with these additional question hours and with the deadline extension. And of course, we have many opportunities. Some were already mentioned by you. Then we have the personal question hours. So next week on Monday, Tuesday and Wednesday, there is the possibility that you register in the Teach Center to one of them and have a talk with a tutor where you can solve some problems that you have. And next to those question hours, the general question hours, we have a third thing which you can always do.
Yeah, you can always ask your mentor or ask us on Discord. So there really is a possibility to get help on every day, either with question hours on Discord, with personal question hours, with generative question hours, or just asking a question on Discord. So there are really a lot of options for you.
Yeah, so you're definitely not alone, and please contact us. And one more remark regarding the deadline extension. So we extended the deadline for 5 days, such that you can work for 5 more days on assignment 2, and not that you procrastinate 5 more days until you start for assignment 2. So we really want to emphasize that you have to start and think as the deadline was on the original date, because the assignment is long and you have to do a lot of things. So please really start now and do not say, okay, we have 5 more days, so I can start 5 days later. No, that's not the case. Then you will be probably in trouble. Okay, that was the organizational part. And now we come to the more interesting content, I think.
Yes, so the heap. You need it for assignment 2. We also talked about it last time and in the lecture. So let's get into it. The biggest thing probably is, why is the heap different than the stack? So as we know, the stack changes all the time and the variables on there also change all the time. So the stack is always just available until the end of a function, and it just stores local variables. And the size is also most often known at compile time, so you know which variables are on the stack and also how big they are. Additionally, the stack doesn't have that much space, so you can't store big structures on it. In contrast, the heap, the memory is much more longer available, especially until you call free. So it's also much bigger, and you can put bigger stuff on it. Which brings us to the next important point, which is that it's dynamically resizable. So if you have memory on the heap, you can make it bigger or smaller, maybe depending on user input, which is not possible on the stack. Therefore, the heap is something you really need to use. Yeah.
So I think you want to draw something now.
Yeah.
Is that correct?
So, or maybe just show it.
Yeah.
Okay. So there is a difference between the stack and the heap, because the stack, as we learned, it always grows down. So it starts at the high address, and then when the local variables get put on the stack, it grows down. The heap is different. The heap sits on rather low addresses, and it most often grows upwards, but it also doesn't grow in the sense that the stack grows, because when you allocate memory on the heap, it could be put anywhere, and it's not guaranteed that the new memory you allocate is put directly after your last malloc call. So these are the main distinctions between the heap and the stack. Yeah. So then let's recap the heap functions. You have malloc with just a size, where you can get memory from the heap with the specified size, which returns your pointer to the memory. Then you also have realloc, which has a bit of a different signature, where you can specify the count and the size. And this is the same as if you would call malloc with the count multiplied by the size. And additionally, it also clears the memory, so it sets everything to 0. This is not guaranteed with malloc. Then there is realloc. So if you have malloced or calloced or even realloced memory before, you can call realloc, specify the pointer to that memory and the new size you want, and then realloc will resize the memory for you. The important thing, we'll look at this a little bit later, is that the memory doesn't have to be at the same address than before. So realloc can move your memory, and therefore it's important to from then on use the pointer realloc returned. And then lastly, we have the free function, where we can pass a pointer to memory you previously allocated on the heap, which then frees this memory.
There are some questions in the chat that I might answer now. So is it bad practice to use realloc a lot? That is in general not the case. So whenever you don't know the size of some object and you have to dynamically increase or decrease its size, then you have to use realloc. If we think about the user input, it would be bad practice if we consider each character of some string that's entered by the user separately and always realloc with size +1, and so on. But if you realloc at a certain amount, it's a good practice.
I think that's even our coding standards, that you don't realloc with a user input with every character. That's because that's bad practice, but in general it's not bad practice to call realloc a lot.
And why to use malloc instead of calloc if calloc is something better? The only thing that malloc is better than calloc is that it's more efficient, because it doesn't have to set everything to 0. But in particular for a beginner course, calloc is very fine, so just use calloc and you do not have uninitialized values in your memory that you get from the heap.
And maybe for the last question in the chat, I will do an example on 2D arrays at the end, and maybe then ask you questions after that. I won't demonstrate the free, but maybe it will become clearer. So then let's start with a first example. Okay. So first, we just want to create an array of integer. So let's create an int.
Wrong keyboard layout again.
Let's create an int pointer and save the return value of malloc. We need size of int times the amount of integers we want in our array. So malloc always takes bytes, so we need to take size of int, so generally 4, and multiply it with how many integers we want to get the correct size memory region.
So we have now an array of size 3.
Mm-hmm.
Can you maybe increase the size a bit of the terminal and the code such that it's better visible?
Oh, okay.
I think that's better.
So,
yeah.
Okay. Then, like we did with the stack, I now want to draw how this would look like.
Yeah. So.
Okay.
Yeah. That should be
So
fine.
we have the stack, and on the stack, as always, we have our main function. And then what we are first doing is creating an integer pointer. So on the stack, we have an integer pointer. Let's call it array. Array. And I'll also write the type. So it's an integer pointer.
Mm-hmm.
And now we called malloc on the heap. So this integer pointer is now pointing to some malloc region on the heap. I'll just put it here. So this is on the heap, and there are 3 integers in here. So let's just subdivide it like that, and we have 3 integers. And this and this is pointing to the first one.
So that's the array basically what we have to consist of those 3 integers.
This is clear. So we still, even if we call malloc, of course we still have a variable on the stack because we need to somehow keep track of where our memory is on the heap, and therefore we have a pointer on the stack which points to the heap where our memory is.
Mm-hmm.
Okay, then let's continue with the code. And maybe we want to create a second string on the heap. So let's call it string. And now malloc the size of character times 4.
Mm-hmm.
So now let's go back to drawing. Now we have a second pointer on the stack. Let's draw it like, okay. Let's draw it like that. Now it's a char pointer. We call it string. And we allocated a second region on the heap. This region is now a bit smaller because the character is only 1 byte times 4, and previously we had 4 times 3. So we now have some region which contains characters. So I'll just write char here now instead of subdividing it into 4.
So it would consist kind of of 4 characters.
It consists of 4 characters, so maybe I just like that. It's 4 characters.
Mm-hmm.
And now this character pointer points to the first character here. So now we have a string on the heap, and you can also use it. One important thing is that if you would now do string equals something, this would not work.
Mm-hmm.
Because this is just like a constant basically, which is a character pointer, and we're assigning it to this character pointer. So there's no copying of a string or anything here. We're just assigning a new value to this character pointer here.
So the arrow would not point to the heap section anymore, but somewhere else.
So it would just point somewhere else, and now we basically lost track of where this string on the heap is, and also can't free it anymore.
Mm-hmm.
So just something to keep in mind. You would need to use string copy if you were allowed to use string.h, but I think it's not difficult to come up with some function to copy string around. And now maybe also try realloc. So we want now a longer array than the first one. So let's call realloc. Oops, forgot. We want to resize the first array and then also specify a new size. So maybe now we need 5 integers. So what happened now on the heap is, okay, we have this array here, and we wanted to make it bigger, but maybe there is enough space above this array so that it's just okay, it's bigger now, we are fine, we have more memory. But how I drew it here, we have this character array right on top of the integer array. Now there's no space. And this is why you always need to keep track, need to use the new pointer after the realloc. Because what's happening now is, okay, this memory region is freed. And maybe I'll just shift this down, so this is now this is the same address.
So the character stays on the same part, but we just...
This is the same. I'm just shifting it around so you can see it better. And now above the character array, maybe there's a new section on the heap consisting of 5 integers. And this is pointing to the first one here right now. So the value... Oops, I'm sorry. This, we created a new variable.
Yeah, because we didn't use the integer
We
pointer.
called it long array. So this is pointing here. And what's happening with the old array here? So if we think about it, we didn't touch the variable on the stack. We just realloced the memory on the heap, and we didn't touch the stack variable. So the stack variable here is still pointing to the old, maybe I'll draw it in a different color, is still pointing to where the integer array was before, but it's not there anymore. So this is a problem. We shouldn't use this array variable anymore because it points to a memory location where there's no longer any memory. So maybe it would be good practice to set array to 0 afterwards so we don't use it anymore. Now, at the end of our program, we want to free the memory again. So let's call free. Well, we need to free our string. You can see this, right? Yes.
Yes, everything is visible.
You can let's free the long array. And now I have a question for the chat. Do we also need to free this array here, the first one?
Yeah, so please answer in the chat, and we will come to your questions in a second.
So do we need to free this here? No, exactly. We don't need to free this anymore because this memory doesn't exist anymore. When we call realloc with a pointer to some heap memory, either this memory just gets resized or it gets moved to another location, and the old memory is like freed, so it's not there anymore. So we don't need to free it. And especially since we said, okay, we set it to null here, it doesn't exist anymore. This point here doesn't make sense anymore. And maybe now it's also good practice to set the string and the long array to null. You don't have to do that, but I think it just would be easier to debug if you have some bug in your program where you are accessing some memory you already freed. Then you directly see, okay, you have a null pointer and your program crashes.
There is a question in the chat now, how we can assign some character to our string. So, for example, setting the first character in the string, how can we do that?
Let's switch back to the desktop. We can, for example, just do it like that. We could also dereference string and set it to A. This both sets the first element to A. yeah, or maybe set the second element to B or something. Now you have A, B, and then you can't forget, if you want to use it like a string, you should set the last byte to 0, so we know where the string ends. So this would be an example of how to initialize the string. Of course, that's not very pretty. I think you should use a loop or something, but yeah.
It's an option at least.
Yeah.
Then we have another question. If we use realloc and we increase the size, is then the additional size initialized with 0 or some specific value, or is this not the case?
I don't know. Do you know that?
Not for realloc, it's not the case.
Okay.
So it's the same as malloc for the additional part. So we do not have the comfort of calloc. So if we use realloc, we really have to consider that everything which comes after the previous array might be uninitialized and some random values can appear there.
Yeah, but you can be sure that your data at the beginning of the array you realloc is the same, obviously. You can also just write 0. You don't need the \0. It's the same. It just makes more sense if you're talking about characters.
Let me read through the chat. Then I have one more question regarding calloc. So calloc takes those two arguments, the size of the array and the size of the data type. Of course, you could theoretically multiply those, write it as the first argument and one as the second argument. But why doing this if you can write two separate arguments?
Is it possible to get the size of the array? No, that's not possible. So when you malloc something, you don't know the size of it. So you have to remember that on your own.
Would a combination of both methods, like dereferencing string and then accessing at 0, work? No, because in that case you would dereference twice, but it's just a single pointer. So we either use the brackets or we use the dereferencing.
So if you remember the last practical stream, this operator also dereferences the pointer.
Okay, and there was one more question regarding using malloc in a function. So if we would have this statement in a function, for example, and we want to return the array from the function, we can just simply return array, and then our function is of type integer pointer. However, with stack arrays, this is not possible. This is only possible if you use heap arrays.
Yeah, that's because the heap doesn't follow the rules of the stack. On the stack, everything is deleted after a function returns, but the heap, if you malloc something, it just stays there until you free it.
When you use realloc to reduce the size of an array, does the memory no longer used also get freed? So yes, this is the case. So if you kind of have the half of the array, then the second half of the array usually becomes available again. And if you call malloc at a later point, this part of the memory can be used for this malloc call again. Yeah.
So if you use malloc or calloc in a function to have to free the memory both in the function and in the main, no. As soon as you call free on this pointer you malloced, the memory is gone. So if you call free already in the function, then the memory is deleted, and if you then return the pointer to the main, you just have a pointer to somewhere which doesn't have to hold your data. So it's an invalid pointer now after you call free. That's why we recommend after calling free to set the pointer to 0 so you don't accidentally use it anymore.
Then I want to draw something. Yeah, I want to mess up your drawing a little bit, but this fits nicely into the topic now. So let's get rid of those errors at the moment. If you have two pointers pointing to the same array, for example those two, then you also have to free only once this block here. It's always both pointers refer to the same block on the heap, and if you call free, for example, for that pointer, then this memory gets freed. And for that reason, you cannot free with this pointer the same memory again, because you already freed it before.
Mm-hmm. So were there any more questions?
I think we covered most of them, and how to free an integer array that is declared inside the loop. This refers already to two-dimensional arrays, which we will have a look on later
We'll
in
come
the
to that
stream.
later, yes.
Okay, I think we covered most of the questions. So we continue now. So as always, the code is also on the slides. And now we have a look on what can go actually wrong and what we have to think about. So you basically demonstrated now how malloc, realloc works and how we can use it, how it is visualized, how we have to think about it. And now we want to cover all the cases so everything that can fail when doing it. And we will also show you like a template solution on how to use malloc and realloc such that you really cover all the cases. Okay, so we go to the code again, and I change it a little bit, but it's almost the same as you already prepared. So what have I done? I have defined a constant which has the size 4. Then I have an integer array on the heap, the same as you did before, of size 4 in that case. And then I iterate over the array and set some values there, and then afterwards I also print the values here. Okay, that's what I'm doing right now. Let's compile the thing. So run keyboard layout. And if we run it, it prints 0, 1, 2, 3, and that's exactly what we did. And now everything is fine, and we're done, almost. So there is something which is not correct in the moment, but we can't see it because
it works.
It works, but we can't see the problem. And now, in the last lecture, it was already demonstrated, and we'll demonstrate it again. We have a tool called Valgrind. And we call this with -leak -check equals full, and then with the executable. And I will execute it here. We already see we have one error, but I have to change something. When you want to use Valgrind, please compile with -g, same as for debugging, that you get the line information there. So we run it again, and let's have a look on the output. So it says here we have one error, okay? And so basically it starts here, then we have the output, okay, that's fine, and then heap summary, and then, okay, here is something interesting. And here we have 16 bytes in one block are definitely lost. And it was kind of allocated at malloc, which is located in the main function of our file, valgrind.c, in line 8. And this tells us, okay, we have here this integer array, we have the malloc call, we allocated the memory, but we did not free the memory. So we have to free the memory, and this was already demonstrated by you how to do that. So we call free on my array, and then we do the good practice and say, okay, my array equals null to set the pointer. Okay. We compile it again, we run it again with Valgrind. Oh, now we have 0 errors, so everything is fine.
And we also see that we have the same amount of frees as allocations.
So that's here. But it's always a good sign that you freed everything that you allocated. Okay, but there is something that might happen now, which we have not covered yet. And now I will just copy something. I defined another constant here. And I named this I crash every program constant. And instead of size, I will allocate now memory in the size of the I crash every program constant. So just briefly go through this. You can ignore the ULL right now, just treat them as numbers. And which size does it have? So it's like 1024, so this is 1 kilobyte times 1024, 1 megabyte, 1 gigabyte, so it's 128 gigabyte in that case. And let's see if we can allocate that much memory. So we compile it again, and I just run the program now, and oops, there is something wrong, obviously. We get the segmentation fault. And now we do not know where the mistake actually is. So if this is a larger program, we maybe cannot locate the problem. I mean, it's kind of obvious that it's the malloc here, but let's see how we can find this problem.
Well, you could either use the debugger, because that's always a good idea when you have a segmentation fault. But because we want to demonstrate Valgrind, you can also do it with Valgrind.
Okay, so let's try this as well. We execute it with Valgrind again. And let's see what is written here. And this is some other output now. And we have the first thing that's written here. Invalid write of size 4 at line 13. Okay, where is line 13? That's here. And we have that address 0x0 is not stacked malloc or recently freed. So we want to write something to address 0. And so basically to address null, if we think about the constant. So obviously malloc did not return something on the heap, but it just returned null.
And then, sorry.
No, please.
And then in the first loop iteration, we have I equals 0 here. And then when I is 0 and we dereference my array, and we add 0, then we're just dereferencing the null pointer, which is exactly what this tells us.
So we need to implement a check that checks whether malloc returned null or not. So we want to do this now. So we have, and this is always the case, always after each malloc you have to check whether array equals null. And in the case that the array, the return value of malloc is null, you probably, and this is the case in all assignments, you want to terminate the program, and you always write some error message. So I just write error here, and we return we return from the program with some exit code which is specified in your assignment description. Why is that the case? Because we cannot continue, because there is no memory available, and we would run into these errors. And now let's see what happens if I compile and run the program again. It's just printing error. If I run it with Valgrind, we also have 0 errors from 0 contacts. So this is also fine. We do not have any memory errors here. Okay, is that fine for so far, or are there questions in the chat?
So there are just some questions about the assignment. Or with strings on the heap. Okay. I don't think regarding this.
Then we continue. So I change it now back to the correct size that we can continue in our program. And now I want to implement a realloc here, because I say, okay, my array of size 4 is not enough. I want to double the size. So we have seen realloc. We have to use the return value of malloc, of realloc afterwards, because that's the new array. So my array equals realloc. Which do we want to realloc? My array, and for example 2 times size of integer. Okay, this would be the realloc, and now I could also iterate until 2 times the size of the array, but I won't do this right now. It's not that important. And yeah, let's see whether this works. We execute it. Okay, this is fine. We execute it with Valgrind. Yeah, 0 errors, so everything is fine as well. However, we did again the same mistake as before, because we did not check for null here and the realloc. So if I write here this iCrashEveryProgram constant, again, run the program directly with Valgrind. Okay, we again get the segmentation fault. So yeah, we have to check again for the return value of realloc and then terminate the program. So I just copy it from here, the check, and
we should be fine now, right?
We should be fine.
Because we checked both times for null.
Yeah, it should work, right? So I execute it first this way. We have the error message printed. This is what it's intended to be. We run it with Valgrind.
Wait, we have an error?
We have one error from one context. Okay, let me see what's happening here. So the error is printed. So this is correct. But now it tells us 16 bytes in one blocks are definitely lost at malloc in main line 9.
Okay.
So it tells us kind of, okay, we have this malloc here, and this malloc is not freed because we lost the memory somewhere. So it seems like if we call realloc and it doesn't work, the realloc call, then we then the previous array stays the same.
Still allocated, yeah.
Yeah, so we have to free it. Okay, so we just implement this here. So we free my array. But now we should be fine, right? Okay, so we execute it again, run it directly with Valgrind. Oh, oops. We have still the same problem here. We still have lost our malloc call, so the memory from before, so we still don't free it. But even if we go into this case, we free my array, right? So what is the problem now? What did happen here? Maybe the chat can answer that now.
Do you see where Michi went wrong?
I have to admit it is a bit kind of hard. Okay, yeah, you can't free null. You're freeing null and not the actual address. Yeah, yeah, that's really nice. You're really smart. Of course, we check here whether my array equals null. So my array has the value null, and if we free null, nothing happens. So we have to do something else. We need to keep track of the address which we had in the malloc call from before. And if we assign the return value of realloc directly to my array, we just overwrite it and we lose the pointer to the previous allocated memory. So we need to declare a new variable. I would just call it temp pointer and realloc and store the return value of realloc there. Then we check for the temp pointer if it is null. If this is the case, then we print the error message. We can free my array because we didn't change the my array variable. So it still holds the pointer of the array which came from malloc. And then if we are right, so let's say the temp pointer is null, then we free it, everything is fine. We can even try this now. Yeah, so we have 0 errors now because we still have here null as the return value. We free my array from before, everything is fine. And if temp pointer is not null, so everything worked, we can just say, okay, my array equals the temp pointer, because then we do not need the memory where my array points to anymore because it got realloced successfully, and we can just assign the temp pointer to my array. Okay, now one last question here. I hope we get everything here. I have now the temp pointer with the realloc. Do I have to free the temp pointer as well at the end of my program? Because I'm just freeing my array, but do I need to free the temp pointer as well?
And yes, that's exactly why in the previous example I didn't just overwrite the last pointer. I really created a new one So don't forget to check.
Yeah, and you're right in the chat. Both temp pointer and my array now have the same variable, so that the same address stored, and it's enough to free it once. So it would be again good practice to write here temp pointer equals null, because then at this point we do not care about the temp pointer stored some address, we just forget it and we just continue with my array. And we don't have to free it.
Because otherwise you could easily go back to this code and see, oh, I forgot to free temp pointer, so you free it, and yeah, then you have a double free.
Yeah, which we want to avoid. This would also Valgrind show. If you would free it, if you have a double free, Valgrind would show that. Okay, then I change back this to the original size and we just run it once again, where now this construction also worked. We'll compile it and we run it directly with Valgrind, and we see there are 0 errors, so everything is fine. And now you can really take this code that I've written here and use that for your assignment. And think about what we've done here. We need the check after the malloc. We need to check after the realloc here. And in particular, we always have to free all the memory that was allocated at some previous moment.
So maybe this is just a simple example right now, but in your assignment, of course, you have more than one array. So you do have to free more memory here than just this one.
Exactly. So let's go back to the slides and just so you again have the example here, and just to repeat it what I said here, but that's probably clearer from the example already. If you have a malloc, you need to check for null. If this is yes, if this is the case, then you have to free all the previously allocated memory and you terminate the program. And of course, you have to free each malloc at some point in your program, and it's good practice to set the pointer to null. And also, if your program can terminate in different cases, you need to free the malloc in every case. So if your program stops in ordinary because everything was fine, you need to free the malloc. But also, if it stops with some error message, you also have to free every malloc. And if you use the realloc, then you need to assign the return value to a temporary variable. Then you check for the temporary variable. If it's null, if that's the case, you free all previously allocated memory, including the block you wanted to resize, and terminate the program then. And if it was successful, the reallocation, then you can assign the temporary variable to the original pointer. And don't forget to free after the realloc, but you don't need to free twice, you just need to free the pointer you obtained from realloc.
Okay, so there was a question, when Valgrind shows no errors, can we assume that there aren't any memory problems? What are the things it does not check? So most generally, Valgrind checks very much. So if it says there are no errors, then the thing Valgrind executed didn't do any memory errors. But you can't be sure that there are no memory errors in your program, because, for example, there could be some code path which you didn't execute this time when you check Valgrind. For example, if you have an if-else, maybe you'd execute Valgrind and the condition is true and you check the if part, but in the else part you have a memory problem. Then, of course, Valgrind can't find this memory problem because it didn't execute.
And this also, we can also continue with the next question here. Does Valgrind also check the null check? No, it doesn't, because usually it does not. It's not executed. However, if you want to check the null check on your own, you could simply do, for example, comment this part out and write hardcode null here, and then everything should work. So you can really do that for every malloc and for every realloc. Execute your program then and check whether there are no memory errors when executing with Valgrind. And yeah, last but not least, I also wrote on the slide how to execute Valgrind, but we will not go into detail there because we already showed this. And we have some more topics to continue with.
So let's continue with the two-dimensional heap array. Let's get back into my main function. And before I start, I want to draw something. So
Yeah,
okay.
go switch back.
Yeah.
I think I lost the connection, but we will set this up in a moment. So it should work.
No. Let me check.
How it should work.
Yeah, okay.
Perfectly.
Okay. We want to have a two-dimensional array. Let's first just clarify some concepts and how we call things. So so everything is clear. For example, if we want to make an array with 3 rows and 5 columns, we could imagine it as a grid. So let's just draw it like that.
Yeah, so you see more.
Like that. And then we have 1, 2, 3, 4, 5. So we have a grid, and let's call these things here rows. So what I mean by that is this whole thing here is a row. And let's call that columns. So these things. So I hope this is clear to everyone. Now we want to access this 2D array. So we conceptualize it like that. And now let's think about what we want to achieve. Let's call this array like just R. And we want to access it. So oops. If we want to access this element, for example, we want to access the array at row 1, because this is the row 0, row 1, row 2. So we want to access row 1 and at the column 2. So this is column 0, column 1, column 2.
Yeah.
And we want this one afterwards. So here we have which row, and here we have which column. This is what we want to use. Okay, how could we represent this on the heap? And you only have malloc, realloc, and realloc, so you can directly allocate two-dimensional structures on the heap. Well, for this to work, we could imagine it like we have an array of rows and we are accessing the first row here. Okay, let's draw that. So yeah, like that. This is our rows array, and this is row 0, row 1, row 2. Now, what should be in position 1 of this array? Well, the result of this expression should be a pointer when dereference and accessed at position 2 return this value here. So for each row, we'll allocate another array of the length 5. So let's just draw that. And each of those contains a pointer to the next array. And this has 3, 4, 5. And this has 5 elements. So our array is an maybe if there are integers, int pointer pointers. So it's an int pointer pointer because first we have an integer pointer to here, and then each of these elements here contains another integer pointer to a row in the array. And this is why this here works. Because now, if we access the first element, we dereference it, we get back the pointer. And if we dereference that pointer, we get back a value in the corresponding row. I hope this is clear.
Switch back the camera on. We've seen hopefully everything.
Yeah. Maybe then just continue with the implementation of this.
Okay, so we go back to the desktop, or I think the drawing we will show it once you want to explain something, yeah?
Okay, so maybe let's just define a variable num rows. We want 5 rows, and maybe then also define a variable row length. You can think of this 2D array in other terms instead of rows and columns, but I think this is the most intuitive way to think about it. And we want to create a game board, and each element of this 2-dimensional game board array should contain a character. So we want a character pointer, this is what we said, and malloc it to the size of a character pointer times the number of rows. So we want the amount of rows character pointer. If you go back to the drawing, maybe this is this one here. So here we had three rows, and for each row we had one entry in this array here. Okay. Now we need to allocate all the rows, but never forget to check if it's null. So if it's null 3, I won't do this here because of time reasons. I have to hurry a bit. So let's iterate over the rows. Yeah, like that. So we iterate over each row and then say, okay, game board at element I. So maybe just go back to the drawing. Element I, this would be element 0, this would be element 1, this would be element 2. And we want one row in each element. So we'll malloc this row, which now is size of character, because we want to store character in the rows, but character pointer basically in this array of rows. And we multiply this with row length. And then again here, check with null. And then if it's null, free the arrays of rows and everything and all the rows you already allocated up until now.
So if the I would be 1, then we'd have to free game board at 0.
Exactly. Because maybe just I'll show it in a drawing. If we are here in the loop and allocating this row failed, we still allocated the row before.
So we have to free this.
So we have to free this row and then also this array of pointers. And if this allocation here fails, we have to free these 2 rows and the array of rows.
So there, I have a question now. Is it important in which sequence we free the arrays here?
Do we want to ask a chat or should I just explain it?
Yeah, so maybe we ask the chat. Yeah, is it important that we free those 3 arrays in a specific way? So if this allocation failed, or yeah, it's important, but maybe you can explain why it is important.
So it's not important in the way like in which order we free the rows we already allocated. This doesn't matter, but we always have to make sure to free the rows before we free the game board. So yeah, before you free the game board, so the array of rows, because then you don't have, if you free the game board before the rows, you don't have the memory where your pointers are stored So you basically lost them
Yeah.
and can't free the rows anymore.
So you have that and you free this, then you have no way to go here kind of, because where to go.
Yeah. So you lost the pointers to the rows. Okay. Then let's initialize this game board. I'll call this row now to iterate over the rows. And I'll call this column to iterate over the columns. So this should be smaller than row length.
And you need to set the column to 0 in the for loop.
Okay, what do we want to do now? Well, we have the game board and we have the row and want to access the game board at row. So let's just do it with pointer arithmetic first. So we add row to game board. So example for row 1, we add 1 to game board and then dereference it to get the pointer of this row. Okay, now we have another pointer and we want to dereference this pointer at the position column because this yields us the pointer to the row. Now we want to go to the correct column and dereference this pointer and set it to something. Okay, this can look a bit confusing, but I think it's important to understand to really get the concept of this 2D array. For example, we could also just access it like that. So maybe just a P for where the player is.
Now, is the 1 now the row or the column?
If we think about it, we have this pointer here. Then the 1 is getting this pointer, which means it's the row. So it's the row at position 1. Now, okay, this results in a row pointer and we're getting position 5. So, okay, we are taking, for example, the 0th row and at a specific position. So the second one is the column we want to get. Because if we access the row pointer at position 5, we are getting the column at that position because that's what we saved there.
Then we switch back to the code.
And now maybe just for practice, let's iterate over it once again and print it. So I'll do it exactly the same as before. We have the row length here. Because of course the number of columns we have is the length of a row. So if you do this on your own, really think about what is a row, what is a column, what do I need to access first so you don't mix that up and then get some memory errors. Because if your array is not doesn't have the same number of rows as it has columns, you would access an invalid index if you mix those two up. Okay, then let's just print the character at a specific row and a specific column. Print a new line at the end of a row and let's see if this works. So let's compile it. Yeah, okay. Let's run it and we see, okay, this works. We have, I think 10, one row is 10 characters. We have 5 rows and we initialized everything with the underscore and at row 1, so row 0, row 1, at column 5, so 0, 1, 2, 3, 4, 5, we wrote the P.
And that's what we wanted to do.
And that's what we wanted to do, exactly.
And maybe you can fix now the warning which we had before.
Before that, I just wanted that afterwards we need to loop again, like that. So a loop like that, or like more like that, to loop over all rows and free the rows in a loop. and then afterwards free the array of rows, so the game board. I'll leave this as a homework for you because we don't have any time. But maybe just to fix the warning, let's see what it was.
Yeah, I'm sorry, that's my stuff from before.
Oh, oops, okay, I didn't include the library which provides malloc. So here it says implicitly declaring library function malloc, which just means, okay, here we are using a function which is not declared before. It still works. We don't get into why now, but always include stdlib if you use malloc. Okay.
One question is there. So
Mhm.
if we free the rows, do the rows pointers then point to null?
If you set them to null, yes. Maybe it would look something like this. You go over the rows again, and then call free on the game board with this row.
But
So
yeah,
it doesn't point to null now. We just freed the memory, it just points somewhere. If we want it to point to null, so we don't make any mistakes afterwards, we can set it to null after freeing it.
And then
So we go over all rows, and then for each row we free it, we set it to null, and then at the very end we can free the game board.
okay, now we really
Yeah.
cleaned up everything again.
And for cleaning up, if malloc returns null, this you can really do now as a homework.
Yeah. So we really showed more than we wanted to show.
Okay, of course you have this example in the handout.
Yeah,
Then
and that's the end of the stream for today. Just briefly summarize what we have seen today. We started with an introduction of the heap function and also drew the stack and the heap and thought about the differences. Then we had the example where we really went through all the cases that can happen when you use malloc and realloc. So if they return null and what happens if you do not free and how to detect these errors. And now at the end we saw a two-dimensional array, how to create it and also how to free it now. Yes, okay, so
the slides are always on the course website. So at coding.geogrants.it. Now let's get to your questions.
yeah, we have to move once to the right. And now you should be able to write questions. I hope at least. It seems a bit odd to me that
And maybe if you can't find it on the course website, it could be a little confusing. You just have to click on this thing here if it's not expanded. If you click on this arrow here, you see all the slides we have up until now.
the Menti seems a bit odd, so maybe we can go back and can you restart the presentation maybe? It's interesting.
Maybe just reload the site, I don't know. Oh, okay.
Ja, okay, this looks much better.
Okay, wie kann man das 2D-Array in eine Funktion packen? Das kommt erst darauf an, was du mit in eine Funktion packen meinst. Wenn du meinst, es in einer Funktion erstellen, genauso wie ich es hier jetzt gezeigt habe, erstelle es und dann kannst du es auch returnen. Solange du es noch nicht gefreed hast, kannst du es dann überall benutzen, wo du willst. Und wenn du meinst übergeben, dann kannst du einfach den char Pointer an die Funktion übergeben und dort auf den Memory zugreifen, den du dir davor allokiert hast.
Are we allowed to split A2 into multiple files? Yes, this is possible. You can do this. So this is supported by our makefile. But please make sure that you really know how to split C code into more than one file. We will not demonstrate this.
Yeah, and including C files
is not the correct way.
And also be careful now, because we adopted the C file. If you have multiple C files in your project, they will all get compiled and you will get an error message if you have multiple C files with a main function.
Yeah. Yeah, so regarding...
I think 75%?
Yeah,
Yeah.
so we have those two categories, which is the functionality and the style. And for the functionality, you can get a deduction of at most 25% for memory management. But it can be less if there are only very small errors. So a maximum of 25% deduction, but it would be great if you fix all the memory errors.
Yeah, because a memory error most often also means an error in your logic.
Yeah.
Okay.
Let's continue.
Okay, this is not quite true. Maybe just very quick. This is the same as dereferencing array plus I. We know that. So what if, because you can turn around the sides of the plus and still the same happens, so this is also possible, which would be equal to this thing here. And that's a very simple explanation why this works, because this is just a plus operation. It doesn't matter in what order you do it, so yeah.
However, for two-dimensional arrays, I would be then a bit more careful, as it's written in the question. So please don't use that, because it should be readable, your code. So yeah, if you are able to solve assignment 2 with one-dimensional arrays, then this is fine as well. But I think it can be helpful really to think about the whole simulation as a two-dimensional array, and for that reason we showed it to you. Maybe we can briefly show that, as there were many questions regarding that topic.
So if you would want to allocate this board in a function, we could just write a function allocate board and then return the game board from this function, and then in here just say allocate board, and this would work. Okay, it would not work because we don't have the num rows and the num length, but it would work like this.
Yeah, so we really can have this in a function, and the only thing that we have to be careful about is the return value, because it's a character pointer.
Yeah, and the important thing is freeing something here is wrong, because as soon as you free it, it's gone, and you still want to use it in the main. And it's the same memory you're using in the main if you're returning this pointer. So this memory still needs to be available, and you can make sure that it is available by using malloc and not a stack array.
Yeah. Are you allowed to create a type def struct to represent a string for assignment 2 and then work with this string object?
Yeah.
Yeah, it's okay.
I don't think we'll...
Yeah, basically it was the lecture team who decided to do that this way.
You can write a love letter to all of us.
Ja.
Ja, ich glaube, die Frage ist ein bisschen älter. Das ist genau das, was wir hier gemacht haben. Wir haben das zweite Array außerhalb von der Main erstellt.
Ja.
Und du kannst es dann natürlich auch außerhalb der Main verwenden. Wenn du jetzt eine zweite Funktion hast, die einfach, keine Ahnung, den char-Pointer als Gameboard nimmt, kannst du natürlich hier drin sagen, okay, wir wollen 00 auf irgendeinen Character setzen und dann das Gameboard dorthin übergeben. Und das würde funktionieren.
Ja. Ich meine, ich sage jetzt noch was dazu, magst noch mal den Code aufmachen, bitte. Wenn wir ein realloc verwenden möchten, dann müssten wir jetzt aufpassen. Also wenn wir in der doStuff-Funktion unser Gameboard reallocken möchten, dann ist das eine ganz andere Sache, Also das aufpassen, aber solange wir nichts am Gameboard verändern, können wir das machen.
Dann müsste man sich überlegen, ob man das Gameboard als Input-Output-Variable macht oder vielleicht einen neuen Pointer returnt und dann immer, wenn man die Funktion aufruft, auch das immer assignt. Also da muss man darüber Gedanken machen, aber im Prinzip kann es so einfach sein.
Ja, solange man nicht reallocken will. How exactly could the drawing of the elevator state happen? Just a basic ID to the race, or what is the key? I can't imagine the problem drawing that complex elevator adapting to the user input. Yeah, basically in the elevator, you can visualize the elevators as a two-dimensional array, and then you just iterate through this two-dimensional array in a clever way. So you have to print it like row by row, because this is how a terminal would works. And then you just access the two-dimensional array at the correct indices. So if you store the array, I don't know, that the first line of the elevator is with index 0, then we start with row 0, column 1, column 2, and then we continue. And this is just like a huge double for loop.
Yeah. And maybe just to note, because this could be confusing, maybe it's not the best idea to really store the string representation of the elevator, but just pick some clever representation of the elevator, and then depending on, I don't know, how much elevators you have, you just have to print a different amount of characters.
Yeah. So do not store like those, I don't know the representation exactly, but those minus signs and the separation lines, please do not store them somewhere. Just store really the internal values, the relevant values. So where is the elevator, how many people is it carrying, and so on.
Yeah, and then when you have the number of elevators, just multiply it with some constant and print that many minus, for example, as separators.
Yeah.
Ich glaube, das haben wir jetzt beantwortet. Weil es ist wie das Gameboard, nur wir haben hier jetzt praktisch ein Array aus Strings, wenn man jede Row als ein String betrachtet. Natürlich können wir auch hier drin einfach praktisch nur einen Char-Pointer, keinen Pointer-Pointer erstellen und den returnen.
Also einfach einen Stern überall weglassen praktisch. How can we do a string as return value in a function?
Okay, yeah.
That's the same question.
I don't know.
Maybe I'm not I'm not completely sure, but maybe you write outside of the allocated memory.
Yeah.
And then you write something after the memory that you allocated, and this is needed to organize the heap internally. And if you write something there, then your program crashes because this information is needed. Yeah.
But you could also post the screenshot of your error message on Discord, but please don't post your code.
And try to debug it with Valgrind, because it will certainly show you where the error happens.
This is also a good idea. Okay. Do they do casts today or?
Yeah, but in this case, I think.
Char too.
So if you have an array of characters, then you just free the whole array and not each character by character. So you cannot free just a single character. You can always free the address of it, and you cannot free certain parts of the array. You can just free the whole array or nothing. Yeah.
Malloc always works within these blocks. For example, if you malloc 10 bytes, then you also need to free these 10 bytes or realloc them, and you cannot free one of these 10 bytes.
Yeah.
You always have to free the whole array.
Ja, also es ist so, dass alles am Heap gespeichert werden muss, was jetzt eben von den Eingabewerten abhängt, aber soweit ich jetzt weiß, ist das für fgets nicht der Fall. Also das ist am Stack okay, aber alles andere, die ganze Repräsentation, die muss wirklich am Heap sein.
Ja. Und für den Hotelnamen dann weißt du ja auch nicht, wie lange er ist. Weil das kannst du dann ja eigentlich auch noch nicht am Heap-Stack machen.
Also wenn du eine ganz exakte Antwort willst, schreibst du das nochmal auf Discord, bitte.
I'm not 100% sure. I mean, what you could do, maybe just some idea, when you're creating this array here and it returns 0, just use another loop in here that iterates from 0 to the current I, because all previous malloc must have succeeded, because when a malloc fails, you return.
So you basically need a second loop there and free everything.
So a for loop from 0 to I, and then free, or maybe I minus 1, and then free every row.
I think so too.
Yes.
Ja, kann man beliebig groß machen. Die Frage ist, will man es so groß machen? Ja, genau.
Ja.
Die Eingaben dürfen, soweit ich weiß, am Stack sein, aber eben die ganze Hotelrepräsentation eben nicht. Ja.
Yeah. If you mean the function headers in terms of comments, then you have to use them, and you can use header files for multiple files. Yeah.
Ja, also eben das braucht man jetzt einerseits für die Repräsentation, wo sich die Lifte befinden, aber man wird auch ein Array brauchen, soweit ich das gesehen habe, eben für die Leute, die noch auf den Lift warten. Also man wird mehr als nur das zweidimensionale Array brauchen.
Und es muss auch nicht zweidimensional sein.
Man kann es auch eindimensional machen, wenn man will.
Und eigentlich kann man auch jedes zweidimensionale Array auch einfach eindimensional darstellen, indem man einfach eine Row nach der anderen speichert.
Ja.
Also das funktioniert auch immer. Das ist komplett euch dann überlassen. I'm not sure.
I don't know that by heart, but
if it doesn't specify in the assignment description that negative numbers are not allowed, then they are possible.
Yeah. We can ask to provide the desired number of bytes for the rows. I don't get the question.
I mean, maybe you mean when malloc returns null. So if already the first malloc call here returns null, then you don't have to allocate any rows and can just return. I don't know if this was your question, I'm not sure.
I don't get it neither. And last question, should the function headers be in the header file? So yeah, if you create a header file for the functions, then you can also write the comments there. But if you just put everything in the a2.c, as most of you will do, just do it as you did it as in assignment 1. Okay, and with that we are done. And yeah, we only have 10 minutes left until the lecture starts, so we have to stop.
Yeah.
And have a nice lecture, and we wish you good luck for assignment 2.
Yeah, have fun.
Bye.
Bye.